I think it's about time to get started, but hi. It is about noon Eastern Standard, and I'm going to write a compiler. It's Amnity says Poggers, and welcome. OMG, please tell me this is going to be recorded because I have to go. Yes, I literally just started the recording, and the beginning of the recording is going to include this bit saying that I just started the recording. So we're going to have lots of fun today. Don't worry. I think I'm definitely gonna put this on YouTube. Probably gonna put it on my website if it'll fit. I don't know if ZDN will be able to handle this much data, but I guess there's one way to find out. So, yeah. So, let's just go over this. What do I call this? Do I call this a creation? Let's call this a creation. Let me just summarize this creation. So, is that actually loading? Okay, so in a fit of rage a while ago, I wrote a satirical esoteric programming language called H. And when you search for it, it's supposed to be searched for by the term hlang. Because just H by itself wouldn't be significant enough, but hlang, you know, there's the money. So basically, you give it H and it outputs H. It has very fast compilation. It is completely safe and also entirely deterministic. It has 0 asterisk dependencies, where the only dependency it has from the environment is the moral equivalent of the putchar function. And I bet a lot of people in the audience can see where I'm going here. And it has a simple grammar that gzips to 117 bytes. It also supports all of these exciting platforms and full internationalization with the Lojbonic H, which is a ASCII single quote. And there's some testimonials like, "This solves all of my problems. All of them. Just not in the way I expected it to. H is the backbone of my startup." Yes. Oh my gosh. The freaking documentation page. Okay, I'm gonna break some of the magic here, but, okay, so the way that I implemented this documentation page, oh my gosh. If you don't have JavaScript enabled, it just says coming soon, ... But if you do have JavaScript enabled, it says it's coming tomorrow. So that it's always going to be here tomorrow. I love that so much. And, you know, there's frequently asked questions like, how do I use this? What version is H? And then there's the H code. The H code is beautiful. "And Jesus said unto the theologians, Who do you say that I am? They replied, You are the estological manifestation of the ground of our being, the kyrgma of which we find ultimate meaning in our interpersonal relationships." And Jesus said, "What?" Some time passed, and one of them spoke, "H." Jesus was enlightened. I think I adapt this, like, I think this part is like a well-established joke about theologians, and this last part was just when I felt the inspiration, I just had to write it down. But yeah, so I'm gonna show you how the compiler works. Oh, actually, I'm not using wasm time. I'm going to be using WA0. So here's how the hlang compiler works. I used Go's text templating feature, the standard library, and This gets passed a string to the template, and it will like iterate over every character of the string from the input. And if the character is equal to 32, which, what is ASCII 32? Is that 0x20? That's a new line. What? I have new line support in this? No, wait, is 0x20... 0x20 is character 30... What? ASCII 32... Or ASCII 10. 10 has to be new line. Yeah, it's new line. Okay. So yes, this is a new line character. So basically it puts 3 locals in the WebAssembly stack. WebAssembly is a stack-based virtual machine, but it also has, like, I don't want to say named variables because they have numbers, but they have numbered variables called locals. So what you do is basically you like pre-declare all the local variables you need, and this is in the more sloppy style. Like the literal WebAssembly code would probably look something like i32.const 10 to put the i32 constant 10 into the stack, local.set 0 to pop the value from the stack and then set it to that local value. Oh yeah, let me translate this to some more recent WebAssembly text format. Yeah, I wrote this a long time ago, if you can't tell. But yeah, it basically loops over the string and writes the relevant program to there. Dot help. Okay, so we have the ability to output a WebAssembly binary and the ability to output the WebAssembly byte like text format that it generates. So let's call this simple.lat and simple WASM. So basically what I'm going to do first is I'm going to show you like how this works, because this is kind of a marvel of engineering right here. So when you pass it a program such as the letter H, what it will do is it will compile it, it will run it, put the output into some temporary buffer, and then give some like information about how long it took to run it. Gas is the number of instructions that was used. I believe the WebAssembly virtual machine that I used for hlang originally was made for like buttcoin stuff. Hello, Jude Jackal, welcome to the stream. And no, this is not based on Antler. You have been tricked. It's actually based on Peg, mostly so that I could make an Urbit joke. Well, thanks for the sub, gmem underscore. Yes, D Marby, this is advanced shit posting. Okay, so the program that it generates is going to be something like this, where it creates a new WebAssembly module, which imports the function h.h from the environment, which we can imagine is putchar, the C function putchar. And then it defines a function called h_main, which is like our entry point. And so then we set all the locals. We declare all the locals. We set them, and then we print the character h, and then print a new line. And then that's the end of the function. And then we also export this function as h. Hello, C. Lauren. Welcome to the stream. But this is actually a very simplified view of it. Because if we actually look at what the disassembled WebAssembly looks like, we get this. So, you know what? Let's actually put these side by side so that it's a bit simpler to see what's going on here. Okay, so as we can see, they're both declaring modules because it's a WebAssembly module. And the main difference is that the disassembled one has these type sections up here. WebAssembly is a strictly typed virtual machine, and its main types are, I think, int32, int64, float32, and float64. There's some other types for things like exporting memory regions or something, but hlang does not need to bother itself with such trivialities, so we don't need to worry about that for this. hlang requires no linear memory in order to operate. So what these types are the types for both the imported putchar function and the type for the function that is defined by the user. So type 0 is a function that takes an i32 parameter, and this i32 parameter is the character to print. Yes, I'm a VTuber. Be afraid. I'm explaining WebAssembly as a VTuber. So we can also see that, this $h reference has been transformed into this zero, this crying zero, because it's telling the WebAssembly stuff that it's function 0. And as we can see here, we have this pattern of, call putchar local.get1, and then we have local.get1, call putchar. I wouldn't have skipped comp sci if classes were like this. Oh, we're doing some crazy bullshit today. Don't you worry about that. And then finally, it exports our custom function under the name h, because why else? And we're saying that export as h for function 1. And this is function 1, which has type 1. Nothing but the finest crazy bullshit. Okay, so that's exciting enough as it is, but let's look at that in a hex editor. Okay, C4, I think I used. Here we go. Okay, -I, no. What was it for getting it in a C file? There we go. So, now we're going to take a look at the raw bytes of this. So there's a reason why I chose to do this in this exact format. So so what I'm doing now is I have taken this WebAssembly file and we are looking at the raw bytes, like the actual contents of the file, because we're going to write a compiler that deals with WebAssembly directly. We need to have an understanding of what the WebAssembly, binary format is. And, we could do this the normal way by reading the specification or, something sensible, but I think it's more fun to take it to a hex editor and look at things directly. So the first thing that we notice are these 4 characters right here. We have a null byte, we have hex 61, hex 73, and hex 6D. you might notice, for those of you that have done C programming bullshit before, 0x61 is inside the printable range of ASCII. And specifically 0x61 is the letter A. If you have a bunch of like numbers of letters of the alphabet 1 through 26, you can add hex 60 to them and get printable ASCII versions of those characters. It's kind of cursed. But what this is null ASM, which is the magic number for WebAssembly. And then the next line is 01000, because this is, I believe, a little endian encoded 1. I think. Yeah, it's a little endian encoded 1, which is the version of the WebAssembly file. Lots of room for expansion, so they can have up to like 4 billion versions of the WebAssembly standard, just in case. Okay, so now we're getting into the part where we read sections of the file. In WebAssembly, each file is broken up into what are known as sections. And these sections are like literally different parts of the file. Like, you know how there's these, the module has a type section, it has an import section, it has a code section, and an export section. Those are all the sections that we're going to need to worry about, so I'm just going to take it a bit slow and we're going to break it all down. So the first section is 0x1. At least that's the type. Or the kind of the section is the first byte, and it's, you can have up to like 256 sections. I think there's ways to do custom sections which have names, but that's too many bytes. You know, our hlang programs have to be about 69 bytes. Nice. And that means that we can't really put like custom strings things in there. So we have this section 0x1, which is the type section. And the next byte says that it's going to be going for 8 bytes, including this one. I think. Does that include that byte? Oh, 5 following bytes. Right. Okay. So, let's break this up a little. And I'm going to put this here. And I'm going to put this here. Okay, so this is type section. 8 bytes long. 2 entries. And the first is a function type, 1 param, 1 i32 param, 0 return params, 0 return values. Okay. And for this, we have another function that takes 0 parameters and returns 0 values. Function type 0, function type 1, 0 param, 0 return. So, you know, that's our type section. And I believe this next one is the import section, 0x2. Let's check the WebAssembly spec. Oh, look, a spam bot. How do I ban them? Report. Spam. 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 Block. How do I remove them? Restrict. No, what do you do? No, you don't. Oh my gosh, I don't want to pin the message. Oh my gosh, okay, I accidentally pinned the message to the freaking chat because I'm a freaking moron. Okay. Binary format. The import section has the ID 2. So if we go back to this, we see the import section has an ID 2. Okay. The import section is 7 bytes long. Okay, so 1, 2, 3, 4, 5, 6, 7. I'll move the next section down. So let's read the spec again just so I'm on the right thing. So the import section has a section which is a vector of imports. The import has a module name and a... what the hell is NM name? Okay, so it has a module name and a field name, and then that has an import description. Or it has a module and a name. So in this case, the module is H and the name is H. And I know that H should be ASCII 68 or hex 68. Yeah. So we have a module name, which strings are encoded with like the number of bytes in the string and then the literal string contents. So what we should be looking for is like we should see 0x1, which means that there's one import in this section. Oh, okay. So then, oh yes, here it is. Module H, name H, and then it's going to have the type index and the function number. So all of this equates to this line of WebAssembly text format. Hi, I made this chat app. Please give me feedback. I can't really do that while I'm disassembling WebAssembly by hand. Have you ever played the video game TIS 100? Those kind of games are dangerous for me, so I try not to. If you can understand. Okay, what is section type 0x3? Oh, function section. The function section has an ID 3. It decodes the vector of type indices that represent the type fields of the funcs in the funcs component of a module. The locals and body of the respective functions are encoded separately in the code section. Okay, so there's also a function section to worry about. So the fact that the disassembler is showing things like the func and code section mixed together is probably so that I can understand things better. Okay, so this is a func section, and it is 2 bytes long, and that should be is that func1 has type 1 or type 1 has func1? Let's assume that it's function 1 that has type 1. So our custom code, which I believe is down here, I think this is our code. I'm not sure yet. I think we're getting to the bottom of things, but this might actually be the export section. Yeah, that does actually look like the export section. Okay, so we have a func section here, which is 2 bytes long. It has function 1 of type 1. So now we have section type 7. What is section type 7? Oh, it is the export section. So the export section has a vector of exports, and each export has a name and an export description, which has either a function index or and then the type of the function. Or no, it just has the function index. So let's do some more disassembling. So we know that this is going to be 5 bytes long. 1, 2, 3, 4, 5. So we're gonna say 1 entry. We're gonna say it has the name H. And we're going to see that it's a 0x00 export, which this says is a function. And then the next byte is going to be the function index. So we have a function which has, or func IDX, okay, not function type 1, function 1. Cool. And now I think we get to the exciting part where we actually like look at the WebAssembly code. Code section has the ID 10. Okay, in hex, you go 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. So hex 10 is hex A is ASCII 10. So this is the code section. And that is 1B bytes long, which is 16 plus I want to say 11, so that's like 27 bytes long. Let's say that's 27 bytes long. You know what? Just to amuse myself, 0x1b the decimal. It is 27. Okay, I can do math correctly. Cool. So we have a code section that's 27 bytes long, and 1 entry. And then here comes the fun part. I think this is the part that I don't totally understand that well. Let's double check though. Let me pull up my notes from yesterday. I actually did some preparation for this stream yesterday where I went mostly through this process, and I believe I did actually get some things wrong. Oops. Okay, so 0x19. Oh, wait, this section's 1B bytes long, which is 2 more bytes that if we take this byte and this byte, that ends up with 19. Oh, so then we just end up with that. Okay. 25 bytes long. Okay, so now here comes the fun part. Are you ready for the fun part? Okay, so now let's look at the WebAssembly spec just again to think about this. Okay, so a func has a vec of locals and then expressions, where expressions is arbitrary WebAssembly bytecode, which we're not going to worry too much about the details here, but locals has the U32 of number of things and the type. So what we should see is that there is one local declaration, 3 I32 values, which roughly lines up with this. These 3 bytes line up to this line of WebAssembly text format. Oh, I see the bytecode now. Okay. Yeah, after a while, you just sort of end up, like, seeing the patterns in things. Because 0A is decimal 10, so we're loading 0A into there, and E8, which sounds wrong, but that might actually just be leb 128 encoding that's confusing me. Have fun, Rumi 4. Yeah, I'm pretty sure leb 128 encoding is confusing me here. But let's go double check against the bytecode spec, I guess. Instructions. We have reference instructions. We have variable instructions. Okay, so 0x21 is local.set. Okay, so let's do this, maybe. I know you can't see what I'm doing, but just bear with me. Oh my gosh, okay, I see it now. So with this knowledge, we can roughly, like, estimate what's going on here. So the first one we have is we're pushing an I32 constant to the stack. That's I32.const, right? 0x41, I32.const, okay. And then we're setting the local 0. And leb 128 is confusing to me. I might actually have to, like, use a proper leb 128 library for this, but I believe this should be I32 const 104. Sounds about right. Oh, this would explain why it wasn't working yesterday, because I was doing leb 128 wrong. What is hlang? Hlang is love. Hlang is life. It is a programming language that I wrote. I guess it's a programming language. Like, it's kind of a creation. By the way, Lib 128 is the like format that WebAssembly encodes stuff into. Like in the binary file. Can I get to Fang with hlang in my stack? Sure. Let's say you can. So if we also go back up to the variable instructions in the WebAssembly spec, we see that local.get is 0x20. So this next one is get local number 1, and 0x10, I think that's call. At least, you know, if we're going by the pattern here, we have the constant set, constant set, constant set, and then we have the local get, and this has to be a call instruction. Let's double check against the spec though and see if I'm right. Numeric instructions. Vector instructions. Oh, that's for like SMID crap. Okay. We don't need to worry about SMID crap. Oh, yes. 0x10, and it's given a func index to call it. Okay. Yep. Okay, so this is our WebAssembly file. This is all we need to know. Okay. So now let's write this in Go. Let's write the nguh compiler. So I'll make a new folder for nguh. Package nguh. Wait, what the crap? Oh, wait, no, I'm blind, never mind. Okay, I thought I messed something up here because this says it's function type 0, but the first byte is 1 because that's the number of parameters that it has. But that's actually because it's the 0th entry in the array. Okay. So, let's make a little abstraction for WebAssembly sections because I feel like this is gonna help a lot. Kind u in 32. No, wait, it's a byte. No, we're going to be using uint32 because of the library that I'm using, so we're just going to use uint32 everywhere. Len uint32. Oh, can you share the terminal, please? Yes, professional internet streamer. I'm, you know, absolutely an expert at internet streaming. Oh, right. Go has you declared structs as structs. Okay, so we have a section which is... No, I need capital S, otherwise my editor will yell at me. Is a WebAssembly binary section. Okay, so now what we need to do is, you know what? Let's make a function that lets us like record the data of the section. Actually, you know what? Let's make this a bytes.buffer, and this will make things easier down the line when we're writing individual like opcodes and such to it. So we have func s star section, and we want to call this write to io.writer error. And what this is going to do is this is going to take all the section and all the data in its buffer and then write that. So if you in 32 s.len, no language server? Okay, now I have a language server. Bang equals s.data. Oh my gosh, is it not going to let me do that? Okay, so let's go to the bytes.buffer documentation in the Go standard library, and we have len. Len returns the number of bytes of the unread portion of the buffer. Okay. We want to compare that to the length of it. If that's not the case, then return s.len equals that abomination. Leb128, what was that package? Yes. Okay, so I'm gonna copy a URL from my other browser into here, and we're going to see this package called leb128. Package leb128 provides functions for reading integer values encoded in the little endian base 128 format. It's used in the debug info in normal binaries, or in like Linux binaries, and it's also used as the binary encoding for all integer literals in WebAssembly. We can probably get away without doing this, but I'm scared, so I'm just doing it. Okay, so now I show the editor again. Write var u in 32 s.kind if underscore comma error colon equals that error not equals nil, return error. And now we do .len. Okay, perfect. Wait, s.kind. Oh, we have to write it to a writer. So we write it to, you know what, we'll call it out. Write it to out, and then underscore error colon equal if underscore error colon equals io dot copy. We copy to out from and s.data. Error not equals nil. Return return error, return nil. Oh, holy crap, that worked. Sweet. Okay, so now that we have sections doing there, let's not call that write, let's call it commit. And let's let's make a bunch of constants for WebAssembly section types. Section type import, and then section type func. Section type export. In reality, there's like way more section types in WebAssembly that allow you to do a lot more fancy things, but like, we don't need to worry about that too much for this. And like the magic number and stuff, I'm just going to hard code that in and, you know, just treat it as a literal that I just prepend to the top of everything, because that's just a bit easier, because we don't need to worry about anything other than version 1 WebAssembly files. I don't think version 2 exists yet. Okay. So now we need to make like func compile. Node or tree peg dot node. Because I'm gonna feed the AST directly to this, because I think that's more fun. And this is going to return the WebAssembly bytes or an error. And we're just going to have it return nil nil by default, because that's the way we roll. Out colon equals bytes dot new buffer. And now this is the part where I'm going to just copy all of this out of my reverse engineering buffer and into here. Cool. And then we're going to return the output buffer bytes and no error. Cool. Does that build? Go into nguh. Expected package found import. Oh, right. That's why my language server is freaking out, because I didn't do Go correctly. Okay. Now I'm seeing the things that I should. Okay, I'm just a moron, don't worry. Okay, so now let's start writing all of the sections. So we're gonna make a new section, and we're gonna say kind is section type. And there. I'm gonna say it's a type section. And we're going to write some more bytes to it. I'm mostly just going to copy a lot of this directly because, like, you know, it's already commented. We already did the reverse engineering for this, but it's not super exciting. You know what? Let's make a constant for const WASM I32 type equals 0x7f. WASM I32 type. Perfect. It's gonna look ugly as sin. You know what? Let's make a couple more constants just to make this easier to read when I look at this next and wonder what the hell I did. And func export export func is 0x60. It's another thing from the spec that I'm just going to have you take on faith. Export func. Export func. Okay. And we commit it to the output. If error colon equals that, error not equals nil, return nil error. fmt.error f You know what, we're gonna do it slightly nicely and give like error messages for my future self here. So yeah. And now let's write the import section. Section type import. We're gonna write more bytes, and we're gonna be able to copy this directly from the disassembly because we're not doing anything exciting here. We need to just delete these parts where we have the section metadata because that's going to be written for us. And then we can commit the import section. Actually, you know what? These need to be pointers to sections because of how I wrote that function. Otherwise, it won't compile. Will it compile? It will. Okay, cool. So now we write the func section. For the record, this is probably not the best way to write a WebAssembly compiler. But then again, you people come into this knowing that I am not exactly going to be teaching, like, the best type of computer science here. I'm going to be teaching hacky computer science. The fun stuff. Okay, and now let's do the export section. Or, right, I have to commit the section to the binary. Okay, so... section type export. export s.data.write. This video should be called WebAssembly, the fun stuff. I'm gonna come up with something clever for when I eventually turn this into a blog post, because this is way too cursed to not have a blog post associated with it. Like, oh my gosh, this is way, way too cursed not to have a blog post associated with it. Also, the name nguh is a reference to the YouTuber Agma, who runs a YouTube show on conlangs called nguh, which is it's kind of devilishly hard for people to pronounce if they're not used to weird sounds. And I mean, like, I do conlanging, so I'm used to really weird sounds, but yeah. Okay, here comes the fun part. Now we're going to actually be compiling the actual code to WebAssembly. Okay, so let's do the fun stuff. So now we need code s : equals and section type code. So now we want to have bytes of data. Okay, so we have one entry, and we don't know how long it's going to be yet because we need to figure that out. So what I'm going to do is I'm going to I'm going to make a new buffer, and we're going to put nothing in it. Okay, so we're going to do a literal translation of this code here. So let's actually, you know what? We can cheat here a little. We want to take these bytes, and everything from here to here is all of the boilerplate involved in this. So we can just have one local declaration with 3 i32 values. And we set things for like new line and for the single quote, there we go. Okay, if tree dot kids dot if len tree dot kids equals 0, else for underscore node : equals range. Okay, so why I'm doing this is because each node has a name, which is like the name of the thing in PEG, and text, which is the actual like character to be printed in it. And if I just have like a single H, it won't have any children, so I need to handle that. So you know what? Let's make something that compiles a single node. compile one node, node star peg dot node, and then we need an output, out io dot writer node peg dot node error. Okay, so switch node dot text case h out dot write byte slice. Okay, so the h is local number 1. So what we can do is we can write this bytecode right here directly to it. If underscore comma error colon equals out dot write that error not equals nil. This is not exactly the best Go code to read. Sorry, future me, and for people watching this. Return error. Case single quote. We're gonna need to get local number 2 because that's decimal 39, which is the single quote or the Lojbonic H. So let's adjust the bytecode here. Default. And as is tradition with the hlang compiler, all the error messages are in Lojban. So I need to find the one error message that I wrote yesterday in fairly broken Lojban. Oh, here it is. And this basically says, like, this letter is grammatically incorrect. Okay, so if error colon equals compile one node bunk buff tree error not equals nil, return error nil error. And when we loop over each node, it's not nested because hlang is not a language that needs a very complicated compiler setup. Yeah. So now it'll compile every node in the AST to that. And finally, we want to print a new line. So and we're doing this in the laziest way possible. And what's also important is this 0x0b opcode, which is it signifies the end of the function. Let's pull up the WebAssembly spec and see if I can find this. Let's go to binary format. Code section. Conventions. Modules. hydration time. Hydration has been achieved. I swear, when I looked at the documentation yesterday, that was it. That was documented here. Welcome to H2Oville. Yeah, I should get some more H2Oville. Oh, expressions are encoded by their instruction sequence and terminated with an explicit 0x0b opcode for end. Okay, so yes, that is the end of function opcode. Cool. And okay, so now that we have this, we can what we can do is we need to write the function to the code section. So we need to specify how many bytes it is. So leb128 dot write var int 64 to out, and that is int 64 of func buff dot length. If underscore comma error colon equals that, error not equals nil. Actually, wait, no, I need to write an int 64 for this stuff here, don't I? Var uint 32. I think that's probably fine. Let's double check the spec though, because I might be doing it wrong. Structure. Conventions. Oh no, that's conventions for the document. Grammar. Values. Bytes encode themselves. All integers are encoded using the leb128 variable length integer encoding. Unsigned integers are encoded in unsigned leb128 format. Okay, so let's look at the modules section. And let's look at, for example, the type section. Okay, what is a vec? Vectors are encoded with their U32 length followed by the encoding of the element sequence. Okay, so that means that this needs to be a 32-bit integer. Var uint 32, uint 32. Yesterday I described Go like this. Imagine if a useful program like awk or sed was incompatible with everything else. I mean, Go's not that bad. It's just kind of awkward if you're not used to it. And then let's copy the rest of the function there. Hello, Silver. I'm writing a compiler. It's the nguh compiler. Let's write some tests for the compiler, because I've written a lot of code and I haven't tested any of it, which is kind of terrifying. So, it's for the hlang. It's for hlang, Silver. So let's make this in package nguh. Func test compile. T star testing.t. Save. Okay, so now we have a test. No, I made hlang a while ago, but the problem is that I did it really terrible and hacky, and now I'm actually writing a proper compiler. You'll have to see it in the recording, but I actually did like go through like the entire heckin' yeah, I did actually go through the entire heckin' WebAssembly binary that my old compiler generated so that I can explain each step of it. Yeah. Good old reverse engineering. Okay, so now imp one equals and peg node text equals h. Okay, so result error colon equals heckin' compile imp if error not equals nil t dot fatal error JSON dot new encoder os dot standard out dot encode result. This is an incredibly hacky way to like basically, so this is a byte slice, and a byte slice is just like arbitrary data, and it's not safe to print arbitrary data to standard out. So what I'm doing is I'm encoding it as JSON, which, by the way, what it will do is it will take the byte data, like the byte slice, convert it to base 64, and then shove that into a JSON string so that I can like test it manually with things. It's awful, but it'll work. So we do a test and we get that, and you go test, and then we go down. We put this down to foo.b64. Vim foo.b64, and we'll just remove the go test detritus. Cat foo.b64 base 64-d to foo.wasm. Now, I'm off by 3 bytes. Fuck. Okay. What did I mess up? Okay, so let's do this. Oh, this is probably gonna be a pain in the ass. Okay, so we want C4. No, actually C1 here. No, let's do C2. No, it's off by 1. C4, yeah. Actually, you know what? I can do it like this, and then IC2 / simple. To old.text, nguh.text, old.text. Okay. This is not what I wanted, but okay. So going through that same reverse engineering process, we can immediately start seeing all of the different sections in the WebAssembly binary. So here's the type section. The type section is 8 bytes. 1, 2, 3, 4, 5, 6, 7, 8. Here is the to section. The to section has 7 bytes. So we go here, I think. Wait, what? What the heck? Error, multiple import sections. What? Oh. What? Section type import. Okay, so there's our first problem. Using Emacs inside of Tmux instead of using Emacs as the multiplier. I'm off by 3 bytes. Okay, I did not make the iOS app use less than 15 megabytes of RAM. That was not me. I've actually not been involved in much of the actual product development at work. What I have been doing though is shit posting. A lot of shit posting, in fact. Invalid section code 25. Okay, cool. Okay, so actually, wait, can I do this a bit simpler? Oh, no, it's because you have to put a space there. There we go. Oh, yeah, I want C4. C4, boom. Okay, so immediately looking over again, we can see all of the different sections at play. Wait, what the hell? Okay, so invalid section code 25. What is 25 in hex? 19. Oh. Oh. Oh, this is incredibly wrong. Okay, so what we have here is section 7, which is... What is section 7 again? That's an export section. Okay, let's go over to our export section here. Okay, so let me break it up where WebAssembly thinks that, where the WebAssembly interpreter is thinking that things are wrong. The one thing I'm most jealous of Z for is the ability to not have to use a corporate Sona at work. This really reminds me of the scene from Lane where the professor points at some assembly on the ward and Lane fucking dissociates. I mean, I've worked with WebAssembly for long enough that like I don't see the individual the bytes anymore. It's just brown, blonde, brunette, redhead. But okay, what's going on here is that we have an export section. It is 5 bytes long. It has 1 entry. The first entry is of type 1, or the first entry has 1 character name. Has a 1 character name, and it is 0x68, which is H, and it has type 0. But where is this coming from? Okay, so there's some magic numbers here. 0x19, that's off by 1 from new line, so I don't know if that's relevant. 0x7f, that strikes me as a number that's important. Wait, what? Did I just write things out of order? Wait, is that what I'm doing wrong? Okay, so we have the export section, we have the code section, and we do that. Oh my god, we are doing it out of order. Oh, I'm an idiot. Okay, I did do it wrong. Oh my gosh, I did it fucking wrong. Okay. So what I did wrong here is, what I need to do is copy this to the code section data buffer from the func buff. Yeah, after you work with a lot of this stuff for a while, you end up seeing the patterns. You end up like being able to subconsciously read WebAssembly bytecode, like just the bytes. It's kind of freaky when it happens. Okay, so what I need to do actually is once I have the function written, then I don't write this to there, I write it to the code section's data buffer. Yeah, okay. Yeah, you're gonna hangy at me. Aren't you supposed to build the compiler for a lang and the lang itself as a flex? H does not have if statements. It can't be used for that. And okay, now we commit the code section because I'm a friggin' heckin' moron. Okay, that looks a bit better. Holy crap. Oh my gosh. We have the same output byte for byte. We even have it like, yeah, nailed it first try, obviously. Because I'm a friggin' computer science expert person. Okay. Okay, there's the feeling of success. Oh my gosh. I just watched you get dopamine in real time. Yeah, I mean, like, that's the thing. Like, this shit's better than drugs, and I should know. I was addicted to drugs for a while. Don't do it. Don't do drugs, kids. Compile.go. Okay, and now we get to rip a whole bunch of crap out. So all this right here is for like compiling the WebAssembly, the program to WebAssembly from like a Go template, which does work, but no, I'm not doing that anymore. And we're gonna remove the WebAssembly text format from this because, you know, it doesn't exist anymore. So we'll have some bytes error colon equals the nguh dot compile tree. If error not equals nil, return nil error. Oh wow, I actually had a bug in here for a while. Wow, because I'm a genius. Binary is WASM bytes. And then we remove this temporary directory crap, and we remove the, you know, creating a WebAssembly text format crap, and we remove doing executing a sub process and setting the result that way. Okay, so now let's see if I broke it. Oh, right, I'm gonna need to rip out the thing that writes WebAssembly text to there because that doesn't exist anymore. So... oh my god. Oh my god, it works. Fuck yeah. Okay. I think we have successfully modernized the H compiler here. I'll have what she's having. I'm keeping foo.text there. I'm gonna move it to disasm.text in nguh. Let's add some package documentation. It's the next generation universal hlang compiler. Yeah, outputs WebAssembly directly instead of using... nguh gives you hlang. Instead of shelling out to wat to wasm. It is not known to have any bugs that are not features. Suckless HQ9 plus. This is even less. This is even more suckless than HQ9 plus. Oh, right. I have to run. Okay, so let's So now here's the ultimate test. Will it work with the H playground? Undefined. Yes, we want it to be undefined. You cannot define this. You know what? Let's remove that bit. http.go. Oh, I might want to show my editor. It might be a little bit important. I still love this, like, coming soon page for the documentation. That's so good. Oh my gosh. What this will do is, I explained this earlier, but for people that joined after I did it, it will say coming soon if you don't have JavaScript enabled, but if you do, it will say that the documentation is coming tomorrow. Let's update this domain as well. Oh my gosh, I can say that I removed a dependency from hlang. What version is 0.1? This will hopefully be the only release. Okay, so now we just get rid of the AST box. "2023 is the year of hlang." Yeah, or something. But yeah, this is how I used to write JavaScript before I wrote ZAct. Like, it'll be fine. It's not the most elegant. Like, I use an on-click for running the thing. Like, it's fine. I also, like, do then chaining instead of, you know, like, normal ways of doing things with async JavaScript, because I didn't understand how to do async JavaScript at the time. Oh, yeah, I actually pull in the CSS from another one of my websites. You know what? Let's see if we can get that error message to show up. queue. Oh, right. It would help if the server was running. Just a little bit. That's right. I have a parser bug. I have a parser bug. If you put anything that's not legal, it will just stop parsing things. Oh my god. Oh my heckin' god. And it won't actually do a direct kind of your input, I don't think. Yeah, okay, you know what, let's fix the grammar if we can. I don't know if I have the tool to generate the grammar installed, because... I had to have it at a very specific version. You know what? This is... We're saying that this is a feature, and that the grammar is buggy on purpose. You know what? Should I write it up as a blog article? I should, shouldn't I? I should also probably, like, figure out how to deploy the fix for this. Git add dot, git commit sm. Fix compilation error forever until there's a bug. Then I'm also gonna clean up the imports. I mean, I am fixing it forever. Or if Goblin Mode could code. I mean, blog slash hlang markdown. The next generation universal hlang compiler. Tags. hlang. Satire. What's another good tag for this? Because it's going to be rendered as hashtags when it gets posted to the Fediverse, so... I'll come up with another one that way. Alright, wait, there's a series for this, isn't there? E-data... No. E-doll... Series descriptions. Oh, H. But I need to use hlang. Google Winter of Code. Oh, yeah, the tags, my blog engine is very hacked up. I need to fix a lot of things. Like, a lot of things. Git Alright, I already did push it. Okay, so cd code mixos configs packages. Go into here. Oh, it is pulling hlang from there. Oh no, okay. Oh, it's not pulling things the right way. Oh, this is going to be a huge pain to deploy. Okay, I'll just deploy it to a different place for the next generation one. I'll fix it later. Okay. Okay. Oh, I need to add WASM here. Proxy auto configuration compiler. The Virgin over-engineered blog versus the chat actually static. Okay, my blog is over-engineered for a reason, and it's mostly because, like, if I don't over-engineer it, Hacker News will take it down. Okay, so now's... I rewrote the compiler. Why the old compiler was bad. Go template abuse. Bit rot in the template. Shelling out to WASM to WAT, or WAT to WASM. You know what? Maybe let's not put it at satire and write it slightly satirical in the serious voice. And yes, my website is faster than serving static files because it skips the file system layer. It was a hack that I made as a joke, and it shows. Where is my phone? Oh, it's not in here. Okay. Let me find a transcription of nguh.
nguh.
Okay. Are you planning on using io_uring? I will when it's available. Yeah, okay. The other, when I was working on this yesterday, by the way, I had somehow managed to create, I didn't use Leb 128 encoding correctly, so I had somehow managed to create a hlang compiler that can't print the letter H, which is hilarious, but the nguh compiler outputs WebAssembly directly. nguh outputs WebAssembly directly, and it IOU ring is available where I'm running my server. However, Tokyo, the Rust async runtime that I'm using, does not have WebAssembly support or not WebAssembly support, but IOU ring support fully stable for my needs. I'm not brave enough to write my own async runtime, so I'm not brave enough yet. I may be in the future. Okay, nguh outputs WebAssembly directly. For HLang's runtime, including compiling code, is fun to say. Okay, so what else should I go? I should go over the architecture, shouldn't I? Or actually, like... explain binary format of WebAssembly. Leb 128 encoding, and what else is the important parts? Oh, this is kind of nice. Okay, so now here's the part where I'm not sure, because I recently got the domain within.lgbt, so I could put it at like paste disasm.txt. Explain nguh compile steps. Write preamble. Write each section, or write magic numbers up to the code section, and then write code section preamble loop through the syntax tree. Or no, let's say walk the syntax tree. Yeah, walk sounds like a good word there. Write to final.wasm file. Run. Yeah, I should probably put hlang on the within.lgbt domain because that's gonna be more fun that way. Okay, what's a sufficiently dramatic sounding programming thing I could say here? Like, in a world where the average program has hundreds of dependencies and simple tasks take forever to compile, we have a new hero, hlang. Oh, left pad, okay. This is left pad. We're introducing left pad. Okay. Where is left pad gonna fit into this? Okay. In a world where simple tasks have hundreds of dependencies and most of them are not documented. Everything falls to chaos. The monolith igarchy dictates that your build times must be slow so that they can win over your hearts and minds. With video games that you play during your compile times. One person gets mad about their string padding library being used by corporations without paying, and then the entire internet explodes. Hlang is the sledgehammer that will break down this complexity and deliver you a truly uncompromised development development. Okay. No left pad. Okay, I did reference left pad. Their entire string padding library. Because, like, this actually was what happened with left pad and why the person deleted it off of NPM. Because, like, this person was maintaining a library that became critical to the functioning of the internet and was not being properly compensated for it and got angry. No, it's actually kind of sad. Like the story for open source funding is totally horrible, and it's why I have a normal like coding job instead of like doing this fun shit the whole time. Yeah, like FOSS sustainability is just absolute dog shit, and watching Silver experience it is why I want to avoid having to be at the whims of random people as long as I can. If none of this is making any sense, please read the rest of the series. Like, it is honestly terrifying. Oh, I don't have all the articles for hlang properly tagged. Cool. Off screen, I'm just like grabbing a link to the Go standard library context documentation. Yeah. Also, I don't think it's totally fair to say that I have like a coding job anymore because I do developer relations, which, you know, like you could say that a lot of things I do are developer relations. There was one major flaw with hlang in the past, though. It was a hollow shell of itself and had wrought to the slains and arrows of time. The playground stopped working so people could not demo the sheer might of hlang. not understand by playing with it. So, lo, behold, a new compiler was born. In this article, I will describe the nguh compiler and how it revolutionizes the ways that you use hlang for both professional and personal uses. Okay, now I'm gonna get out of that voice because, like, that voice is hard to write in. Like, the kind of voice that I was going for was, like, kind of edgelord teen that read too much of the King James Bible and Shakespeare. And, like, I can do that voice. Like, I used to do that a lot when I was talking to people normally because I was that kind of cringelord. But, let's just go back into the normal writing voice because that voice is physically painful in order to write in. Holy crap. Let's see. 24 viewers. Wow. Unintentionally setting new records while writing about terrible compilers. The old compiler was a hack. The program source code as a string to this Go template. I don't have a syntax highlighting thing for Go templates, so we're all just going to have to imagine. And I have to find, where is the old code? Okay. Where else can we see dreams of not VLANing in real time? Okay, okay, so I have to admit, part of this is satire on VLAN. I've tried not to admit this in the past because, you know, I don't want to, like, directly shit on that guy, even though, like, they behave in a way that is kind of deserving of it. But, like, it's not entirely a VLAN, a shit post about VLAN. There's also some Urbit satire in here. Like, you know, behind the scenes look. This part where it says that it has a simple grammar that gzips to 117 bytes, this is a reference to one Urbit thing about its VM called nguh, where they were, what was it? They bragged that its spec could fit onto a t-shirt and that it gzipped to like 1,000 something bytes. If it fits on a t-shirt, I don't want to hear about it. Exactly. This template works by taking the program input as a string and looping over each character to decide what to do. If it was a new line, it would print a new line. If it was a space is 0x20, which means that's 32. Okay. If it was a H, it would print H. Was a single quote. Oh, there's actually a bug in this compiler. The architecture is deploying modules to WebAssembly so they can be swapped out easily. Okay, so each hlang program actually doesn't need any like each hlang program doesn't actually need memory. Like, this is literally just using stack locals, which are okay, so basically it's using registers to do it. So in theory, you could run this in a WebAssembly interpreter that doesn't have any memory in it. In practice, the WebAssembly interpreter is probably going to stick a linear memory block in there anyway, but you know, we don't actually use it here. And the parser spec. Oh, what did I say here? 117 bytes when gzipped. Which means that it can fit on a t-shirt. Oh my god. Oh my god. I should unironically get a t-shirt with the hlang spec on it. I should make that. Oh my god. Oh my god. Should I include this part, like, up here, where it's, like, describing, like, the parser metadata? Or should I just include this part here? Wait, 117 bytes when gzipped. And this is 118 bytes. Oh my god, we saved 1 byte by gzipping it. Means that it can fit on a t-shirt. I mean, to be fair, I don't think Urbit started out as a Buttcoin project. It just sort of, like, transformed into it. WASM. As a QR code, oh my gosh, that's beautiful. Additionally, this would then use the command wat2wasm to compile it to a web... Oh, right. You need to see my editor if you want me to see what I'm typing. Additionally, this would then use the command wat2wasm to compile it to a WebAssembly file instead of doing it directly. This, combined with the fact that the get local instruction was renamed to local.get in the text format sometime in the last 2 years, means that not only was my compiler hacky, it didn't work. Apparently, that was renamed before WASM hit 1.0, and the legacy name was an alias they planned to remove. Guess who didn't get the memo? Reverse engineering a binary file on stream and reassembling an identical replica in code. That's fun. The nguh compiler. On December 31st, on December 31st, 2022, I wrote the nguh compiler on stream. The nguh next the nguh gives you hlang, or the next generation universal hlang compiler. The nguh compiler outputs WebAssembly bytecode directly instead of using wat2wasm as a middleman. No, stop jumping around. Let's get the little happy tooth and let's say this means that hlang has even fewer dependencies. Throwback to the time that the Shark Girl had a cameo on the Tailscale blog. Okay, um, I actually got a lot of internal flack for doing that because they were confused about the professional messaging. And don't worry, I have a plan. Uh, I'm going to include the Shark Girl more. I just need to figure out how to sneak it through a bit better. It's to be pronounced with the final sound of ing and if you can read IPA, it's pronounced. Yeah. I mean, I've thought about doing some like investigations of hair and the like, but it is difficult for me to look at Drew DeVault wear and not be like slightly toxic because just out of like sheer exposure from the toxicity that Drew DeVault brings to the table, and I just don't want to do that. Like, I just really don't want to do that, if you can understand. I'm glad that people like it, but I just can't do it. No, I'm talking about, like, basically any post that person writes. Like, I don't mean to be toxic here, but, like, damn, there's a bunch of toxicity over there, and I just do not want to be party to it. Zim. Don't you mean Zig? Yeah, you think you mean Zig. Yes, I've done Zig in the past. I love Zig. I actually use Zig as my C compiler when I can, because it actually has, like, fixed the C compiler stuff. Zig improved. No, you mean Nim. Okay, hold on. I have something for this. What did Bram Moulinar make? Because, like, Bram Moulinar has this... Bless his heart, he has this, like, propensity for making these weird alt-world programming languages that are just, like, fascinatingly odd. And, you know, you end up with things like Zimbu. Like, just look for the hello.zu file. I don't care. You do what you want. I can do what I want. Like look at this hello world program right here. Like, func main returns an int, io.print hello world returns 0, and there's a freaking close curly brace, but there's no open curly brace. Like, what? What? Just what? Yeah, Vim script is also, oh, it's a thing. Oh my god, it's such a thing. Oh my god. This was a joke. What? Oh, actually, there's a new thing. Yes, Vim 8 adds async functions. It's an OCD killer. Like, it literally kills people with OCD. Yeah. New Vim script 8. Yes, it has channels too. What else is there? Oh, yes, it finally added true and false to the language. Yeah, Vim is crazy. Vim script, I don't know how anybody tolerates this. Okay, let's add a little summary blurb for what WebAssembly is. Is you know what? I'm just gonna steal from Wikipedia here. Because, like, WebAssembly is a standard for, like, is a standard that specifies a way to run programs on consumer hardware in a sandboxed way that on arbitrary hardware in a sandboxed way. It is used mainly in web browsers to power things like YouTube's player component, Twitch stream viewing, and by developers anytime they need to put a block of code into a website without having to rewrite it in JavaScript. Why install Chrome when you can open chrome.wasm inside IE? Because IE doesn't have WebAssembly support. I'm part of a slowly growing group of developers that want to run WebAssembly code on the server so that you can take the same .wasm file and run it without having to have the source code and a working compiler setup. At a high level, a WebAssembly module has a bunch of sections in it. Each section contains information for things like what functions the module exports, the types of imported functions, how much memory the module needs, what should be in memory by default. Well, yes, the main problem there is that it's difficult for WebAssembly files to make arbitrary connections to the internet. So, you'd have to hack it so that it uses the JavaScript fetch function somehow. But it could be done. Each section contains information for things like what function the module exports, the types of imported functions, how much memory the module needs, what should be in memory by default, and the function bodies for your code. Here's an annotated disassembly of an hlang binary. And then literally just copy this directly into the page because I feel like that could probably explain things a bit better than I can right now. Yes, but we don't write web browsers in Rust now, do we? We have to write them in C++ so that there's memory safety vulnerabilities and we can make everybody have to emergency patch the entire world at a moment's notice. Imagine writing a web browser in Rust, kick servo under the carpet. Yeah, but we don't use servo now, do we? We all use Google Chrome. Takes all the needed sections and puts them in the target binary. And off screen, I'm linking to the compile function in the nguh compiler. Wanting to do I/O is a mistake for most programs in the first place. The first sin of irreplaceable complexity is depending on some unspecified environment. Yeah, but, we also need to live in the real world, and in the real world, most people don't use, Nix or something, as much as I hate it. Most of the sections are copied verbatim from that disassembly I pasted above. The exciting part happens when I... how do I phrase this? The exciting part happens when the individual, that's spelling individual right? Yeah. The exciting part happens when the individual nodes in the hlang syntax tree get compiled to WebAssembly bytecode. Each node in the tree has its relevant character complete with a... Okay, how do I say this? Each node in the tree has its relevant character complete with a... and maybe a... has... maybe its character to print, and maybe a list of child nodes. A syntax tree for hlang could look like this. This is gonna be like the most inscrutable freaking thing ever. Oh, did I delete the wrong thing? I did. Oh no, I deleted the wrong thing. This can't do. Oh, -P, right? I chose this exact parsing library I did because of a Lojban parser in Go used the same one. No, paste, you freaking bitch. No, oh my god, did it not actually copy it? Copy. Paste. Okay, it did not copy it. Fucking asshole. Do as I say, not as I do. Yeah, that's a big theme for my blog. Like, Oh my gosh. My blog just cursed things so much. Or it could look like this if there are multiple characters in the program. I need something like this. Actually going to be pasting Go code here. Oh my gosh. I have a 32 core processor, so of course Windows is lagging. So either read from the root of the tree or all of the tree's children in order to compile the entire program. Compile one node function will turn the text associated with the node into will turn the text associated with the node into the correlating WASM bytecode. Usually pushing the relevant character to the stack and then calling the h.h char function. It will generate the end of the function, including a trailing new line, and end the .wasm file. There. My only regret is that a single hlang program that is that an hlang program that only prints h isn't exactly 69 bytes. That would have been nice. Actually, how many bytes is it? $67 bytes. What could I do that would put 2 more bytes in the binary? But do nothing. Is there a NOP instruction in WebAssembly? Let's find out. Oh, there is a NOP. You know what? We're hacking the compiler. We're adding in 2 NOPs so that it's exactly 69 bytes. Because I'm an adult and this is my compiler. Okay, will that do it? Wrote 69 bytes to foo.wasm. Here we go. Oh wait, were the NOPs like... Oh wait, the NOPs were just skipped over in the gas calculation. Okay, that's awesome. Yeah, there's 2 NOPs there. Okay, we have funny been achieved. There we go. You know what? I'm just gonna put a base 64 encoded hlang binary there, just in case people want to do things with it. It's gonna be absolutely useless to most people. Gotta go run some errands. Happy New Year to Z and everyone in chat. See you around. Yeah, see ya. Stay safe out there. Remember, if a base 64 string starts with AGFZ, that's probably a WASM module. You know what? Let's put the hlang website on the internet on a new server. To figure out what the IP address of it is. I'm gonna go into the Terraform. Is there a WASM interpreter that will allow you to set up an mmap? I don't think so. I would love to see something like that because I've actually thought about doing M-maps with multiple linear memory regions, but the problem is that most compilers don't support multiple linear memory regions, so that my hands are kind of tied. However, I have been considering making a Holy C compiler that will support multiple memory regions. I just haven't gotten around to do it yet. That'd be exciting. Run a WebAssembly program that modifies a network packet buffer in place. Yeah, that's why I want to do it. Because it would be freaking awesome. Okay, so how do you declare a DNS name? E. Oh, none of this stuff should be super important. Okay, so now what we do is we change. Then we make this, and we create h.within.lgbt for A and quad A, and the IP address is actually going to be different here. Oh, I'm not modifying the compiler. I'm thinking about making like a Holy C compiler from scratch as the blog. I could choose a whole bunch of other languages to do this with, but Holy C seems amusing, so. What the hell is my Vultr password? Oh, it's that, okay. Now I go over to nguh, and I copy its IP address, and I go over to settings, IPv6, and I copy its address. This is the right IPv6 address, right? You know what? Let's ask the server itself what its IPv6 address is. Okay, so it's Tailscale ENS3 says that its IP address is this. Now, let's see if that pings. Or do I drop ping packets? I shouldn't. Oh, I just dropped ping packets, okay. Or does just IPv6 not work? Okay, so this is going to be easier. We're just not going to have IPv6 support for this because I give up. So now I'm going to run Terraform plan and run up my AWS bill. Yeah, this is what happens when you get to my level of SRE. Like you end up having things like this. and you end up having like Terraform files for your own DNS configuration. It's a fucking nightmare. Oh, and all of these are IAM policies because, you know, I had to write my own IAM policies for my own stuff. Of course. Okay, and then apply. Terraform is going to check everything again and be like, hey, are you sure you want to do this? And I am actually very grateful that Terraform is so freaking paranoid, because it being paranoid has saved my ass so many times. You have no idea. Do I want to do this? Yes. Nguh. Yeah, that's what I chose. Go down here. Now I enable the hlang service. And I look at the hlang module, and I have to set the domain. Okay, are there any other relevant settings that I want here? Okay, I don't care about... Oh, use Acme equals true. Okay. Just double check that this does what I think it does. Oh, no, I want the Acme host to be different. I'll just do that. That should be fine. It'll make its own certificate with the HTTP authentication method, but... There. Okay, perfect. We have it replying to pings, which is good enough. And now to Nick's Flake input. Or no, it's Nick's Flake. Which one is it? It's Nick's Flake metadata. I want to update the input for X. There we go. I think that'll do what I want. Yeah, what I really wish you had was like Nick's Flake update X. Because like, doesn't that just make sense? Like... NixOS modules not default. Oh, right. Update the Z site one because I don't think that. Next profile upgrade requires you to say what to upgrade with a regex. Oh, that's cursed. That is so cursed. Getting status of... Okay, let's just comment that out for now. That SSL certificate is used but not defined. What? Oh. I think that's what it's talking about. Nguh config services nginx virtual hosts. Ah, yep, that's it. Okay. Okay, so what I was checking here is that was too fast. I don't believe it. Oh, wait, that never actually did the right thing in the first place because you don't use metadata to do it, you use lock, right? Because it's a freaking undiscoverable ass thing. Yeah, now it's doing the correct thing, I hope. Did something get deprecated while I wasn't looking? Let's show Stream Fox. Okay, we're gonna have to define things the roundabout way, I think. I am gonna have to invalidate that API key. All what? Oh wait, it wasn't shown on screen. I'm fine. Okay. All dev streams are bound to devolve into Nick's streams at some point. Yeah, enable Acme equals true, force SSL equals true. Oh. So what I need is this part. Enable Acme? Is it all caps? Oh, it is all caps. Okay. The Acme module is a little weird. Yeah, it's incredibly weird. Okay, while that crunches, I'm gonna go to the bathroom real quick. That's supposed to be the idle animation? I don't know what is supposed to be my idle animation, for the record. Reset, there we go. Idly contorting my neck? Oh no, how bad was it? Did someone get a like, replay of it? That sounds cursed. Oh, thank you for the follows from, Roomy_4, QU10_, Nick Hartley, and Roger Duran. Sorry, I have not been looking at that. I have been busy doing satanic things. Your head just rotated and moved out of view, roughly speaking. That's incredible. Oh, I love that so much. Okay, and now it should be almost done building my experimental model repo. And or my experimental repo. It's kind of a mono repo, I guess. And now it's just gonna copy all this crap over to the server. I need to get rid of the matrix server on there because it just broke one day and I haven't wanted to bother fixing it. Please don't die. Please don't die. Oh my gosh. Yes! Oh my gosh, yes, okay, there we go. We have working. Head to its new home at h.within.lgbt. If you want to be party to... what would you describe the experience of watching this stream as? I was gonna say, like, the kinds of hostage situations that, oh no, not hostage situation, that sounds a bit mean. If you want to witness things such as this being created live, follow me on Twitch. Or on my VTuber business account at... I need to rebrand my vt.social username. I was gonna have it be like, you know, my shtick was a lowest honest VTuber, but that's a bit too much effort, so I'm going to step down my expectations and just, you know, just have it be like my VTuber business account or something. I don't know. I don't know what the... I'm still trying to figure out the relationship between all these things, but I figure that, like, a VTuber alt is hilarious. And I kind of want hilarious things. VTuber persona. Not like that. Okay. So let's just go over and... Should I have this posted today? Let's have it posted today. In a world where simple tasks have hundreds of dependencies and most of them are not documented, everything falls to chaos. The monolithigarchy dictates that your build times must be slow so that they, the dependocracy, can win you over, or win over your hearts and minds with video games that you play during your compile times. One person gets mad about their string. This is unsustainable. Oh, I'm actually Canadian, but the local time here is UTC because I haven't bothered to fix that yet. One person gets mad about their string padding library being used by corporations without paying, and then the entire internet explodes for a few days. This is unsustainable. hlang is the sledgehammer that will break down this complexity and deliver you a truly uncompromised development experience. Can't spell sledgehammer without H. Better American. Ugh. If none of this is making sense, please read the rest of the series. This will hopefully help something make sense. Oh, that reminds me. Okay. What are the other H articles? You know what? I can check my own FAQ. Okay, the origin of H. A formal grammar of H. Is there hope in making sense of H? Yes, there is. There is hope in making sense of H. Just check the... You just check the dev site. Yeah, that'll link to the H series. That's probably good enough. If you need even more context, check this page for more information. There was one major flaw with hlang in the past, though. It was a hollow shell of itself and had rot to the slanes and arrows of time. The playground stopped working, so people could not understand the sheer might of hlang by playing with it. Lo, behold, a new compiler was born. In this article, I will describe the nguh compiler and how it revolutionizes the ways that you can use hlang for both personal and professional uses. Having 2 years of hlang on your resume will let you get hired by Google. Oh, it's nguh. It's like the and ing and the in uh-oh. So you have nguh. It's not a very Englishy word, which is why you won't really hear it that well, and you'll instinctively misunderstand it. That's why it's beautiful. That's why it's a beautiful name for this, because it's slightly anti-mimetic. Wait, there were professional users of hlang? Having 2 years of hlang on your resume will let you get hired by Google. The old compiler was a hack. The main way it worked was by feeding the program source code as a string to this Go template. You know what? I'm gonna link the Go text/template library documentation there. In case you haven't dealt with it, Go does have a templating library built into the standard library. It's not the best, but you know, it's when you need violence, it'll let you do violence. Like for the longest time, my website used to use Go's standard library templates. They work fine. They're just kind of weird. And you know, I just put this source code in there. The template worked by taking the program input as a string and looping over each character to decide what to do. If it was a space, it would print a new line. If it was an H, it would print H. If it was a single quote, it would print a single quote. Anything else is ignored. However, this means that the parser was mostly ignored. And the parser spec compiles to 117 bytes when gzipped, which means that it can fit on a t-shirt. Okay, how do you figure out the compression ratio for something? Let's just go for the compression ratio calculator. No, that's, computer. You know what? When in doubt and you need to do weird things with numbers, you go to Wolfram Alpha. You say percentage difference between 117 118. This is, oh wait, I have to do it the other way around. Yeah. Enlarge. No, I don't want to go pro. 0.8475%. Oh, I have a script for that. Yeah, I mean, additionally, this would use the command wat2wasm to compile it to a WebAssembly file instead of doing it directly. This combined with the fact that the getLocal instruction was renamed to local.get in the text format sometime in the last 2 years means that not only was my compiler hacky, it didn't work anymore. Apparently, that was renamed before WASM hit 1.0, and the legacy name was an alias they planned to remove. Guess who didn't get the memo? Needless to say, this could be fixed by doing a simple s/get_local/local /.get/g on the source file, but that's not fun. You know what's really fun? Reverse engineering a binary file on stream and reassembling an identical replica in code. That's fun. On December 31st, 2022, I wrote the nguh compiler on stream. The nguh gives you hlang, or Next Generation Universal hlang compiler, whichever you prefer. Outputs WebAssembly bytecode directly instead of using wat2wasm as a middleman. This means that hlang has even fewer dependencies. Nguh is supposed to be pronounced with the final sound of ing and smashed together. It is not phonetically valid in English. It will take some practice to say it correctly. I'm not sorry. If you can read IPA, it's pronounced nguh. The name comes from the YouTuber Agmashwa, from the YouTuber Agmashwa's show about conlangs named nguh. To help you understand the architecture of nguh, it will be helpful to get some context about how WebAssembly files work. How WebAssembly files work. Summary. What is WebAssembly? This is a little expando box right here, so yeah, like for people that don't understand what WebAssembly is, there's a little summary here that hlang is compiled to WebAssembly for no reason in particular. WebAssembly is a standard that specifies a way to run programs on arbitrary hardware in a sandboxed way. It is mainly used in web browsers to power things like YouTube's player component, Twitch stream viewing, and by developers anytime they need to put a block of code into a website without having to rewrite it in JavaScript. I'm part of a slowly growing group of developers that want to run WebAssembly code on the server so you can take the same .wasm file and run it on any hardware without having to have the source code in a working compiler setup. hlang is compiled to WebAssembly for no reason in particular. At a high level, a WebAssembly module has a bunch of sections in it. Each section contains information for things like what the functions the module exports, the types of imported functions, how much memory the module needs, what should be in memory by default, and the function bodies for your code. Here is an annotated disassembly of an hlang binary. And, you know, it goes over the thing that we went over like much earlier in the stream, where we have the magic number, version 1 WebAssembly, the type section, the import section, the func section, the export section, and then finally the code section. At a high level, nguh just takes all the needed section and puts them in the target binary. Most of the sections are copied verbatim from that disassembly I pasted above because they don't need any modification for the binary to work. The exciting part happens when the individual nodes in the hlang syntax tree get compiled to WebAssembly bytecode. Each node in the tree has maybe its character to print and maybe a list of child nodes. A syntax tree for hlang could look like this if it has one character in the program. Input H. Input. Or it could look like this if there are multiple characters in the program. Input HHH. Which means I need something like this. Go, comment, compile abstract syntax tree to WASM. If length of tree.kids is equal to 0, which means that there's only one node in the program, so you have a single character, it will try to compile one node, and if it fails, then it'll throw an error. And if there are multiple nodes in the tree, it'll try to compile them all, and if there's an error, then it'll blow up. Throw back to the time I thought I came up with the idea of a compiler having a logic tree. Yeah, that's a VLang moment. This will either read from the root of the tree or all of the tree's children in order to compile the entire program. The compile to one node function will turn the text associated with the node into the correlating WASM bytecode, pushing the relevant character to the stack, and then calling the h.h or putchar function. Finally, it will generate the end of the function, including a trailing new line, and end the .wasm file. Fun fact, the generated binary for an hlang program that only prints h is 69 bytes. Nice. Here is a base 64 encoded hlang binary in case you find this interesting. If you want to play with hlang, head to its new home at h.within.lgbt. If you want to witness things such as this being created live, follow me on Twitch or on my VTuber business account at z@vt.social. Happy New Year to those that celebrate. There. Now let's just double check and make sure that I'm linking to the right hlang website now. Oh, right. I moved the projects out to that. I think I have hlang in the projects list. Did I define that in the default config? Yes, I did. Okay, so let's add hlang to as a notable project. An esoteric programming language that compiles to WebAssembly. Do I reference hlang anywhere else? I don't think so. Okay, I'm gonna finish the publication off stream, and it's so that I can like annotate the Twitch VOD and such. But yeah, thanks for watching. It's been nice to stream like this again. I'm going to be streaming more in the future, mostly next year. I didn't originally plan to do a stream today, but I thought, you know what? This is such a bad idea that I kind of want to do it. So I did it, and it's nice. Over the next year, I think my next big project is going to be either a book or a class on site reliability engineering, and I am going to be, based on my experiences with it, and I am going to be writing that live on stream, because why not? Having you people around while I write something makes it a lot less boring, and I'll be able to focus better. Anyways, thank you for watching this creation, and thank you for reading them, Byron of 39. Like, oh my gosh, these articles, like about half the reason I'm able to write the articles, like, you know, in, what was that? That was like, yeah, that was like 9 kilobytes, like slightly less because I mostly pasted like a couple kilobytes from there, but like that's at least 6 kilobytes of text in like an hour and a half, and I'm pretty sure that there's probably a couple small grammatical errors here, but you know, Hacker News will tell me what they are, so I don't have to worry about them too much. And yeah, Happy New Year to those that celebrate. And in case you are wondering, this is the 82nd article of the year. 82. I write a lot. I write so much that's like the most based version of the user will fix it. Hacker News will tell me, or people will point it out on Mastodon. Yeah, I did not expect to get that many. Yeah, I've gotten like, I think 10 Hacker News front pages, so that's like a 1 in 8 ratio there. That's pretty good.